In this video, we're going to learn how to summarize variables so we can get descriptive statistics such as the mean, standard deviation, minimum, maximum, and then we're also going to learn how to do correlations between variables. So I'm going to pull open my do file that I have going, and the first thing that I should do is I should probably save what I have done. So I'm just going to save this on the desktop as Stata example, and then that's a stata example.do or a do. So that's the file type that Stata uses for its programming. So I'm going to go ahead and run what we have so far. So I've commented out all the stuff where I've adjusted the data, and I'm just going to use the data in its already adjusted form. But I can go back and I can change anything if I need to from the raw data set. So what we've done first is brought in our GDP, unemployment rate, CPI, and again it has the day, the quarter, and the year variables as well. This time variable is a string. We can probably just get rid of that, and to get rid of that variable we can just type drop time, and then it deletes that variable from the memory. And I tend to drop variables if I have a lot going. That way it just cleans it up and keeps the variables that I'm using in the active memory, so I don't have more to go through if I'm searching for variable names, so forth. So we're going to drop time, and then we want to summarize our variables. So for example, let's find out what the mean is for our three variables of interest. So we're going to sum, that stands for summarize, GDP, unemployment rate, and the CPI. Then I'm going to run that, and what we get in the output is we see that there's 226 observations of each. So 1959 to 1959 quarter 1 to 2015 quarter 2 would be 226 quarters of observations that we have. The average for GDP is going to be, this is going to be in trillions of dollars, so $8.788 trillion with a standard deviation of $4 trillion. And we have a minimum and a maximum, so the maximum is $16.2 trillion. And the unemployment rate, we have our average, standard deviation, minimum, and maximum, and this is as a percent. And then finally the CPI is as an index, so the mean is just slightly higher than the base year. And here's a standard deviation, the minimum, and the maximum. Okay, so that's going to be our first thing, but we may have reason to believe as we adjust these we'll be looking at growth rates, so forth. But what happens if we just want to see what is the average of GDP by quarter? So there's some reasons to believe that some quarters of GDP are going to be higher than others. So we know that in the Christmas season sales go up, so GDP should go up in the fourth quarter. But after the Christmas shopping is over in the first quarter, and we have a strong winter, then shopping should go down and GDP should go down as well. So let's just verify that we might see the fourth quarter higher than the first quarter. So to do that, we're going to use the by command. So we're going to go by year, or excuse me, by quarter, comma sort. So the by quarter is telling us that we're going to group it by the quarter, so it's just going to look at quarter 1 and summarize the variable. Quarter 2, summarize the variable. Quarter 3, summarize the variable. Quarter 4, summarize the variable. And we have to use the sort command to ensure that it's actually using it in the matrix to summarize it appropriately. So it's just basically filtering the data and sorting it out. We put a colon, and then we'll put GDP, unrate, and the CPI. We'll just go ahead and click this. Oh, we need to put the sum, so we need to have that in there, obviously. We'll do that, and here's what we get. So we look, and here is average for all the quarters, so for all of them grouped together, But if we break it out by quarter, we see that we have 57 observations, 57, 56, and 56. So for quarter one, the first quarter of the year, we should see average GDP equaling 8.7 or $8.8 trillion. Second quarter is 8.82. Third quarter is 8.75. And the last quarter is 8.81. So the second quarter actually has the highest average GDP, while the third quarter has the lowest. So the summer has the lowest average, spring has the highest average. But if we're looking at this, we can see that there definitely are differences. We don't know what those differences are yet. We can do a means test to see if these actually differences are significant or not. Unemployment rate basically looks the same by quarter, and the CPI looks about the same by quarter as well. Slight differences, but I don't think they're significant. So the last thing that we want to do is we've summarized the variables, so I know what these numbers are. Another way that we can do this is that we can also say sum GDP, unemployment rate, and the CPI if quarter. We have to have a double equals to ensure that it's actually we're making a statement that if this is actually equal to, let's say, quarter 4. And if we run this, what we see is we have, here's our by quarter, and then here if we have the if statement if we want quarter 4 results only, and sure enough the results are the same between these two. So there's two ways we can do that. We can break it up and get all the quarters at once like we did, or we can write an if statement and get it only if the quarter is equal to the quarter that we want to pull. And we can do the same thing, so instead of quarters we could do it by year and look at the average by year, so forth. Last thing that we want to do is look at correlations. So there's two ways that we can do this. The first way is we can just type in core, GDP, unemployment rate, and CPI. And we run that, and here's our correlation matrix. So we have ones running along the diagonal. Since GDP is correlated 100% with itself, unemployment rate and CPI are also correlated with 100% with themselves. GDP is correlated with the unemployment rate at about 14 or 15%, but it's highly correlated with CPI, about 99%. And the CPI is correlated with the unemployment rate about 22%. One thing that we may want to do is find out, are these significant correlations or not? So we can go through, and instead of using core, we can use PW core, which stands for pairwise correlations. And we're going to do GDP, unemployment rate, and CPI. And let's say that we want to find out if they're actually statistically significant at the 95% level. So we're going to use the star command and 0.05 as the number. So it's going to star everything that's significant at the 95% level. Now if we do that, we get stars at all of them. So GDP, so all these variables are correlated at 95% level with themselves, or with each other. If we go ahead and change this, so let's say, so instead of 95, let's change it to the 99% level. And then we run this, and what we find is the unemployment rate is not 95% correlated with GDP, but GDP is 99% correlated with the CPI, and the CPI with unemployment rate. So this breaks up our correlation matrix so we can see what is actually significant, and obviously we'll find out what this high correlation means at a later date when we're trying to run regressions.